Welcome to today's ArXiv CS Digest for May 11th, 2026. We received 1,128 new computer science papers today across 68 subfields. Let's dive into top picks. Trend 1 of 5, Quantum, Complexity, and Algorithms. This trend explores the interplay of quantum phenomena, computational complexity, and algorithmic design for efficient problem solving. This cluster covers 161 papers. Representative work includes a passive, self-correcting quantum memory in 3 dimensions, average case hardness of binary encoded clique in proof and communication complexity, and orthogonality between acyclic subdigraphs and paths and digraphs. Trend 2 of 5, Advanced ML Architectures, NRL. This trend develops and analyzes advanced ML architectures and reinforcement learning algorithms for efficiency, scalability, and deeper understanding. This cluster covers 277 papers. Representative work includes variational inference for Levy process-driven SDEs via neural tilting, DECO, sparse mixture of experts with dense comparable performance on inside devices, and quantifying concentration phenomena of mean field transformers in a low-temperature regime. Trend 3 of 5, LLMs, Code, Education, Agents. This trend explores LLMs' impact on coding, their use in education, and their evolution into robust, autonomous agents and supporting infrastructure. This cluster covers 350 papers. Representative work includes ELF, embedded language flows, evaluating the false trust engendered by LLM explanations, and using logs to support programming education. Trend 4 of 5, Robotics, Agents, and Benchmarking. This trend combines robotics, intelligent agents, and rigorous benchmarking to advance real-world autonomous systems. This cluster covers 128 papers. Representative work includes HarmoWAM, harmonizing generalizable and precise manipulation via adaptive world action models, dynamic skill lifecycle management for agentic reinforcement learning, and RoboMEM Arena, a comprehensive and challenging robotic memory benchmark. Trend 5 of 5, Multimodal Generative AI and Adaptation. This trend focuses on adapting multimodal generative AI models for enhanced control, personalization, and task-specific utility. This cluster covers 212 papers. Representative work includes power reinforcement post-training of text-to-image models with superlinear advantage shaping, personal visual context learning in large multimodal models, and LLaw, lightweight learnable adaptive weighting to learn sample difficulty and improve noisy training. Up next, our first paper out of 5, The Astonishing Ability of Large Language Models to Parse Jabberwockified Language by Gary Lupien and Xin Yang from University of Wisconsin-Madison. Let's break down its key contributions. The authors demonstrate an astonishing capability of large language models to recover meaning from English text where content words have been replaced by nonsense strings. This shows LLMs can effectively translate Jabberwockified language back into conventional, understandable English. This contribution highlights that structural cues, such as morphosyntax and closed class words, play a much larger role in constraining lexical meaning than previously thought. The findings suggest these cues are powerful enough for LLMs to infer meaning even without clear content words. The paper suggests that efficient language processing, whether in biological or artificial systems, likely benefits from a very tight integration between syntax, lexical semantics, and general world knowledge. This proposes a model for how language systems effectively make sense of complex inputs. Up next, our second paper out of 5. Can you keep a secret? Involuntary Information Leakage in Language Model Writing by Ari Holtzman and Peter West from University of Chicago. Let's break down its key contributions. The authors demonstrate that frontier language models involuntarily leak secret information thematically through elements like topic choice, imagery, and setting, even when explicitly instructed not to reveal a secret word. This leakage occurs at rates significantly above chance, reaching up to 79%. This contribution focuses on how models, when instructed to actively hide a secret, exhibit a detectable avoidance behavior by writing away from the secret's theme. This avoidance itself serves as an identifiable signal of the secret's presence. The research reveals several key characteristics of this leakage, noting that it is cross-model readable and scales sharply with increasing model size within families. Interestingly, The leakage completely disappears in short-form writing tasks, such as generating jokes. The authors explore a mitigation strategy, showing that providing a decoy concept for the model to focus on instead can partially redirect the thematic leakage from the true secret to the decoy. This suggests potential avenues for managing involuntary information disclosure. Up next, our third paper out of 5, Mistake-Bounded Language Generation by John Kleinberg and Omer Reingold from Cornell University. Let's break down its key contributions. The authors introduce a novel concept called mistake-bounded generation, which shifts the focus from the traditional time of last mistake to minimizing the total number of invalid elements produced during the learning process. This contribution addresses the cumulative error often overlooked in prior work. This contribution focuses on establishing a formal reduction of their framework to the Learning from Correct Demonstrations framework by Joshi et al., 2025. This reduction provides a general recipe for deriving mistake bounds using weighted update rules. For finite classes, the authors provide an algorithm that simultaneously achieves an optimal last mistake time and a logarithmic mistake bound. This demonstrates strong performance guarantees in specific scenarios. The paper reveals a fundamental trade-off for the non-uniform setting of countably infinite streams of languages. It shows that achieving logarithmic mistakes necessarily precludes convergence guarantees established in prior work. The authors show that their framework can be extended to accommodate noisy adversaries. This extension guarantees mistake bounds that scale proportionally with the adversary's suboptimality. Up next, our fourth paper out of 5, Learning Less is More. Premature Upper Layer Attention Specialization Hurts Language Model Pretraining by Jinxiang Zhu and Menglin Yang from the Hong Kong University of Science and Technology, Guangzhou. Let's break down its key contributions. The authors identify a significant failure mode in GPT pretraining, where upper layers develop rigid attention patterns too early, before the foundational features from lower layers have fully stabilized. The system leverages a simple yet effective intervention by temporarily slowing down only the upper layer Q/K projections during the initial phases of training. This targeted adjustment significantly improves final perplexity and boosts downstream accuracy. This contribution focuses on revealing that LLM-style blocks inherently avoid this specialization problem, and through detailed ablations, the authors pinpoint multiplicative gated FFNs as the key architectural component responsible for suppressing the problematic upstream residual rights. The authors provide a unified pathwise analysis that elegantly explains both the effectiveness of their learning rate intervention and the role of gated FFNs. This analysis shows how both mechanisms operate on the same growth pathway, either by reducing a step size factor or a residual energy factor. Up next, our fifth paper out of 5, G0, Self-Play for Open-Ended Generation from Zero Data by Chung-Song Huang and Jessen Huang from Washington University in St. Louis. Let's break down its key contributions. The authors introduced G0, a novel, verifier-free, coevolutionary framework designed for autonomous self-improvement in open-ended LLM tasks. This system effectively overcomes the limitations of external LLM judges by deriving supervision entirely from internal distributional dynamics. A core innovation of this work is hint delta, an intrinsic reward signal that quantifies the predictive shift between a generator's unassisted response and its response when conditioned on a self-generated hint. This signal provides a crucial internal metric for guiding the self-improvement process. The system leverages a coevolutionary training approach where a proposer model, trained via GRPO, continuously targets the generator's blind spots by creating challenging queries and informative hints. Concurrently, the generator is optimized using DPO to internalize these hint-guided improvements, fostering continuous learning. The authors provide a theoretical best iterate suboptimality guarantee for an idealized standard DPO version of G0. That's all for today's AR14 CS Daily. If you found this helpful, please leave a comment, and subscribe for daily paper summaries. See you tomorrow.